What is up, most distinguished patrons of this channel? So today we are doing part 3 of the How to TIG Weld series, and it's the time I feel is right to talk a little bit more about machines and do a little bit of book learning so that we're all on the same page about all this stuff because it's confusing. So let's get into it. So I hope this video is reaching you when you have gone through and done all the practice that I requested in the previous video. And practice is key to learning TIG. I can't stress enough how much time it actually takes to really get good at TIG. It's a time investment, and if you're not where you want to be with skills, spend more time. Hundreds of hours it takes. But the payoff is that once you learn the skill, it opens up doors you never thought was possible, because you can actually weld stuff that a vast majority of the world can't. And that is TIG in a nutshell. When you master it, or at least get decently good at it, what you can do is just, it's unreal. And it's my favorite welding process, which is why I'm so happy to be doing videos on this. So anyways, hopefully you did your practice. Let's get that out of the way. Let's talk a little bit about machines. Now, I was going to wait to do this video for, I don't know, a couple more videos in, and then I realized it was kind of an idiotic move on my part to not do this sooner or more or less right away. And what I mean is, talk about what you need to spend to get a functional TIG welder, because plenty of companies out there are happy to sell you a TIG welder that they say is the best thing since sliced bread, and then you get it and you struggle to weld with it, and then you blame yourself that it's your fault, and then you give up trying to learn TIG because it's too hard, when the reality is the equipment that you're using is subpar and it's limiting you. Now, I'll be honest, it's pretty insane the quality of welds you can do with a ridiculously simple welder. You can literally take an old Dial Art 250 or hell, any engine drive welder from the 40s and TIG weld with it and get acceptable X-ray quality welds. So if you're having issues with the quality of your welds, honestly, it's probably more you than the machine. However, there's a ton of features that you want to get so that it just makes learning easier. And by the end of this video, you'll understand exactly what I mean by that. So the first thing I want to talk about is, how much welder do you really need? So this here in front of us is a 165 amp machine. There's a ton of them out there in the 160 amp class to maybe 180. So the smaller form factor machines like this are my personal favorite machines. I love the portability, I love the capability, and you get a decent one, and there's almost no limit to what you can do with them, which is awesome. So my personal preference, if you're in the market to buy a small TIG stick machine and you want to learn DC TIG, so aka welding steel to titanium and stainless, no aluminum, DC TIG, my recommendation would be to buy an ESAB Rogue 200 or a Everlast 161 STH, or a Miller Max Star, what's it called, 161 STH, which, that, don't get me wrong, don't buy that new. They're like $2,000-$3,000. It's not worth that. But if you can pick up one used, or just the one with lift arc, that's a very handy, small, compact machine, well worth the money. Another option you would have would be just kind of like any 200 amp DC or AC/DC TIG machine used. If your budget's a little bit tight, that's another option. And I'm going to put a list of all of the welders that I recommend in the video description so that you have at least a list to look at and understand and maybe consider purchasing. Now, speaking of how much money you need to spend, here's the deal. I'm not here to BS you. I can tell you that if you buy one of them Amazon special TIG welders, expect to have far poorer performance than any of them that I'm going to list in the description. That's just a reality. I can't stress enough how common it is with cheap TIG welders for them not to function the way they should. The most common one, two most common ones, they claim that they're 180 amps, 200 amps, and guess what? They only put out 160. that's kind of a problem because you might need more amperage, okay? The other issue is they lie about how they start the arc. I have tested and seen numerous TIG welders that claim they have lift arc, where you touch the tungsten down and rock it off and it starts, that actually are scratch start, to where that tungsten is live at the amperage you set it at, and the second you go to start it, it's trying to put 160 amps of current through it, and without the skill required, aka you haven't practiced enough, you're going to end up welding that tungsten to your base plate more times than you really want to, and you're going to become very frustrated. So you can't go by what those cheap Amazon specials claim. They all lie. I'm just telling you, I'm being honest. They lie about that. So don't buy one of those. Stick with, as ridiculous as it sounds, something from Harbor Freight, something from Everlast, a used Lincoln, a used Miller, ESAB, a used ESAB. Fronius is another good one. I get it, that stuff, it costs more money than your Yes Welders, your Arc Captains, and all of those, but you know what? You can actually learn on them. And guess what? If you find out that TIG isn't for you or you don't use it, those will all sell for something. Go try and sell a used Yes Welder on Marketplace. You're going to get 10 cents to the dollar. At least a Miller, a Lincoln, an ESAB, any of those, you're going to get at least 3 times that for your money back on the dollar you spend. So that's at least a plus. So stay away from those. Now, as far as features that I consider a must-have, let's run through a bunch of them. This is about as basic as you can get for a TIG welder, and that's not a problem because of the way TIG works, where it relies heavily on the foot pedal for control of heat input. Having a simple rotary dial and not a digital display for amperage is more than adequate to TIG weld and do high quality, literal X-ray quality welds with it. So that, don't be fooled. You don't need anything fancy. And that's funny because a lot of the cheaper Amazon specials will throw in fancy digital displays, and that's all bogus. Don't buy into that. Get something that functions properly. So this very simple setup, that's fine. You don't need anything fancy. This particular welder has high frequency start. My opinion is, if you're trying to teach yourself to TIG weld, buy one with high frequency start. It will save frustration. It makes arc starts far easier, and it's a better way to learn. It does pay to have lift start as well, because sometimes you might not want to use the foot pedal and running a fixed amperage, starting your torch, and not having to rely on controlling it with the foot pedal is a great thing to have. Like when I TIG weld roll cages, that's very beneficial because the foot pedal sometimes is a pain to use. So I would consider high frequency mandatory or close to it. Lift start mandatory. You don't want scratch start. It's too difficult to learn on that, and you're going to get frustrated. Now, this feature has what's called pulse. I'll talk a little bit later about what that is, but TIG pulse to me is not a huge deal. I've been TIG welding for the better part of probably 7 to 10 years, and well, probably more than that now. And honestly, I don't use pulse. It only comes in handy, in my opinion, on thinner fusion welds on stainless steel and maybe super thin material, but I can weld razor blades without pulse. So to me, not a huge deal. Is it a requirement? Absolutely not. Don't look for a machine that has pulse for the sake of having it. You can do excellent welds without it. Now, stick welding capability. This machine, as it says here, can stick weld. Do I think a TIG machine should be able to stick weld? Absolutely. That's one of the huge benefits of TIG, is that when you get a good TIG welder, you get 2 welding machines. You get a TIG welder and you get a stick welder. Now, unfortunately, I would say better than 2/3 of all of the TIG machines out there claim that they'll run 60-10 rods, and they don't. So if you want to get into stick welding and teach yourself stick, you're best off finding a machine that will actually run 60-10. So your Yes Welders and your Arc Captains and all of them, those don't. They might say it and they lie about it, but they don't run it. So if stick is a concern, make sure that the machine in question can run 6010, and that is known to be an overall decent stick welder because it'll save you buying a separate machine. And trust me, if you can TIG, you want to learn stick too. That's just how it goes. Now, this machine has a foot pedal control. You must have a foot pedal with your machine. Now, could you learn to do lift start and no foot pedal? Absolutely. Will it make you an excellent welder? Absolutely. Is that the way that I think you should learn to TIG weld? No, because it takes a lot of time and it's frustrating because of the limitations of not having a foot pedal. Therefore, you must have at least the capability of a foot pedal up front. Even if you don't buy one or it doesn't come with one or you don't use it, that's fine. This machine has a hookup, that's great. You want a foot pedal. Also, some machines do what I call gas through DINs. So this, if you look here, has a O-ring seal and more or less is both the gas hose and the DINs connector. That is really handy for portable units because like my Miller Dynasty has a separate gas hose and it kind of gets in the way of things sometimes. For a portable unit, I would recommend having gas through DINs. It just works super well. The downside is they're more prone to leaks, but the upside is it's easier to remove the torch and it's one less hookup. So that's something to think of. It's not mandatory to have gas through DINs on a smaller machine if that's what you're looking for, but it's something to think of if you're doing portable work. Some other features that you're probably going to want. Gas valve. So this machine, you plumb the gas line into it from your argon tank, and when you press the foot pedal or do your lift arc start, it starts the gas flow automatically. That's very handy for two reasons. One, you don't waste a shit ton of gas because you forgot to shut the torch valve. Okay, so that's very handy. And two, it oftentimes gives you control with higher end machines on how long the gas flows before the arc initiates and how long after. That's really good for welding stuff like stainless and Inconel and reactive metals because you have more control over gas flow. Not all machines will have control on that end. This one is very simple. It just has a predetermined amount before and after the arc starts and ends. So this is more of a simplistic, but having a gas valve is huge in my opinion. Do not buy a machine that does not have a gas valve. Another hot topic, and this is my opinion on it, is dual voltage capability. There's a ton of welders out there that are 220 only, and there's some that do dual voltage. This one happens to be able to do 120 volt or 240. My opinion is get one that does dual voltage. There's a couple reasons for that. In this small form factor, this can be carried to your buddy's house, to a job site, or wherever, and could possibly make you money in the future once you get good at TIG welding, right? Having the ability to run on less than 240 volt power is an immense capability, and I can't overstate that. Because one of the great things with TIG welding is it operates at such low voltage, you can actually get serious amounts of amperage on 120 volt. A great example would be a normal stick welder can only hit maybe 90 amps on 120 volts. Some of the better ones that are super efficient with power factor correction can hit 110, 120 amps. A TIG on 120 volt can hit 140 amps and not even come close to tripping breakers. So that is an awesome capability because it gives you the ability to weld thicker steel without issue, something that's very difficult to do with the MIG process, almost impossible on 120 volt to weld, say, 3/8 steel. Well, guess what? TIG can do it. So having dual voltage capability is big. Now, if the machine's going to sit in your shop or your garage and it's not going to move, yeah, that's not really a huge issue, but it's something you could consider. The other thing is that I find that most of the dual voltage machines actually have better capability or more efficiency and better power factor than ones that are 240 volt only. They put more of an emphasis on the design of the machine to where it doesn't trip breakers. That's good because it means you can run them on extension cords or off of 20 amp circuits and not trip them. Again, going back to the Amazon specials, avoid them for dual voltage, because I guarantee you they're going to end up tripping 120 volt breakers, and they might claim something stupid like 150 amps of stick output on 120. It's simply not possible. They lie about it. Don't believe it. It's all garbage, okay? Something I didn't cover in the previous videos that was a gross oversight on my behalf, and I apologize, has to do with TIG water coolers. Now, this is my Dynasty, this is my primary TIG welder. I do not actually have a water cooler for it, and I'll be honest, I really should. And at some point in the future, I likely will buy one. But a TIG water cooler is basically a secondary box that's typically about 2/3 the size of your main welder that pumps coolant through the line for your TIG torch, through the head of the TIG torch to keep it cool. There's a lot of benefits to that. And people have asked me over the years, well, is that a necessity? And here's the deal on that. If you're doing DC TIG below 160 amps, there's really not a huge benefit to a water cooler. When you approach on DC above about 180 to 190 amps, what you're going to find is that a standard 17 size torch is going to be like not be able to handle amperage, and it's going to smoke in your hands. So a water cooler becomes more of a necessity at that point. Now there's a way to get around buying a water cooler, and that is simply going to a bigger style torch. By upgrading the physical size and amp capacity of the torch, it allows you to run more amperage without melting the torch. The downside is the torch gets stupidly big. When you look at the size of this guy, it's nice, small, compact. When you go to the next size, the physical neck of it is about as big around as this is. The handle's bigger, it's heavier. The cable doesn't flex as nice. So it's one of those things where upgrading to a bigger air-cooled torch or gas-cooled torch might not be the best thing. By going to a water-cooled setup, you can actually run a torch that's smaller than this with a 250 amp capacity. The water-cooled torches are the way to go, but unless you're DC welding above about 180 amps a lot, not a huge benefit to it, to be honest. Now, there is a caveat to this. If you weld on AC TIG for aluminum, this torch will barely be able to handle 150 amps on AC before it starts literally smoking. And that is where water coolers become more of a necessity, is with the AC end of things, because the heat input into the torch via the tungsten is so high that you really need some method to cool it down, and air cooling starts to become inadequate. So if you have ambitions on doing a lot of aluminum welding that's thicker than 1/8 inch, you're going to end up at some point buying a water cooler. So that is something you should be keeping in the back of your mind. Something I didn't mention in earlier videos, but it's very important that you understand, is kind of what I had mentioned earlier, which is there's different size torches. So not only are the torches themselves physically different, but the consumables they often use are different sizes. So it's very important to get all compatible stuff. And it's also very important to get a torch that's rated for the amp capability of what your machine is. Now, this is a 150 amp CK 17 style torch, probably the most popular torch style out there. And it will handle 150, 60 amps on DC without too much issue. But when you start talking AC, this simply doesn't hold up. And I don't know if you can tell by how gray this is. This thing has been almost on fire when I'm welding at 200 amps on AC. So don't do like I do and abuse it. You're not going to get the longevity out of these, and these are a couple $100, so it's not smart. But the physical size of all of the torches does matter, because if you get one that's super big, and by the way, most cheap welders come with bigger torches, it's cumbersome to use. Oftentimes the cheaper torches don't have flex necks. Like, I don't know if this one, yeah, this is a rigid neck and this isn't a cheap torch, but anyways, my recommendation, 100% get a flex neck, because you can position it in your hands to get a better angle easily. it's the way to go. So that is something worth investing in. Now, when you get good, it doesn't really matter. You can use a rigid neck like this and weld everything perfectly no matter what for the most part. So for learning purposes, great, not a necessity realistically, but get one, okay? A lot of the cheaper welders out there will often come with either an undersized torch, meaning it's a 200 amp machine and it comes with a 150 amp torch. Expect to upgrade that if you do a lot of welding. Or they'll come with a jumbo sized torch because it happens to be cheaper and they're just throwing something in to call it a TIG welder. And again, that will limit your capability because of how big it is. So expect within the first 6 months to a year, you're probably going to end up upgrading the torch on your machine unless it comes with a decent one out of the box. So factor that into your budget. Let's go on and do some book learning. The first thing I want to talk about is pulse, what it is and what it really buys you and how it works. So pulse is something that is somewhat unique to TIG welders. You very rarely find it on stick welders, and on MIG machines it's still very uncommon because MIG with pulse tends to be what they call spray arc, and most home hobby machines can't do spray. But if you understand pulse with TIG, you'll understand how pulse kind of functions with other welders as well. So we're going to make an assumption that you have a 200 amp TIG machine that has pulse. Say you set the machine to do 100 amps. So we'll call this 100 amps. That's what the set point on the machine is. At 100 amps, it will pulse between 100 and a lower current. So on some machines, like the Miller Dynasty, you can 100% control what that lower current is. So you could say you want it to be 30% of your 100 amps. So then that would be 30 amps. So as the arc cycles through its pulse, it drops from 100 to 30 back to 100. Simple machines like that Harbor Freight Vulcan, the pulse is not adjustable. So your resting current, so the amperage when it's not at peak, is not adjustable, nor is how long it spends at the peak versus the resting current. So simple pulse machines, it's basically more or less like this. It could be 50-50 or 75%, 25%. So long story short, it's not adjustable and it slightly lowers heat input. The reason it lowers heat input is because 100 amps, if you were at 100 amps and you were full pedal, your line would look like this for heat input. Well, with pulse, it more or less drops below that. So over time, your average heat input is something like here. So it lowers your overall heat input, but oftentimes allows you to maintain decent fusion because of the higher amperage. Now, in reality, pulse tends to lower penetration and fusion depending on circumstances, more so than you're not going to gain penetration in most cases, but what it does do is buy you more time with very thin material to not burn through. So that can be a benefit. There's a couple things you got to keep in mind with this. If you have a 200 amp class machine, universally, if you set the machine for 200 amps and turn on pulse, you more or less, your peak current is going to be 200 amps. It will not go over that. So what happens is that if you need actually 200 amps, like say with aluminum, if you're trying to pulse aluminum, any addition of pulse at max output will only lower heat input. That's kind of a problem because 200 amps on aluminum isn't that much. So pulse tends to be more effective on steel and stainless than aluminum, because to get an effective pulse on aluminum, you really need to be up in the 300 amp class machine or higher to get an effective pulse out of it. So that's something to keep in mind. The other thing to keep in mind is that pulse is not beneficial on a lot of materials out there, like your tool steels and your high carbon alloys. If you start doing pulse where you have a very low resting current and a high peak current, you can end up getting cracking as you're welding due to the thermal changes, the heat input changes. So this is not something you want to make a habit of on any material in all circumstances. Another important thing when selecting a machine or understanding the TIG process is how much amperage do you really need? So how big of a machine to buy and how much amperage is practical to use to weld something. In a case of steel, and steel would cover basically any kind of alloy of steel or cast iron and that sort of stuff, a ideal range would be 0 to 160 amps. At 160 amps, you can basically weld unlimited thickness steel. You could weld 1-inch thick steel with that. Now, I'm not going to lie, it's going to be a mighty slow process to be welding 1-inch thick steel with TIG, but guess what? You could do that. Unlike with the MIG process where you need a significantly higher amperage machine in order to weld thick steel, TIG has an awesome benefit of a 160 amp machine like that Harbor Freight being able to fully weld 1-inch thick, 1/2-inch thick steel without any trouble. So I would recommend as a bare minimum for your first machine, 160 amps. Now, as you get better with TIG and you're able to do weaves to try and get more metal down, you could use up to, I'd say, 180 to 200 amps for a TIG machine for most things. Now, duty cycle does play a role. If you plan on welding at 160 amps all day long, guess what? A 160 amp machine, if that's its max output, won't be able to keep up. In that case, you need to be at a 200 amp class. But for all functional purposes, 160 amps is the bare minimum that you want to have an effective TIG welder. For stainless steel, most people don't weld stainless over about 3/16 inch thick, so for all practical purposes, it'll actually take a little less amperage to weld stainless, and you can weld unlimited thickness with 150 amps, but for all practical purposes, let's just call it 160. Now, where the very interesting problem comes up with TIG is aluminum. Aluminum requires a massive amount of heat input. And that is because, one, the bead that you put down is extremely wide, and a wide bead means a lot of metal needs to be melted. Two, the aluminum disperses heat, so it conducts heat so well that it pulls heat out of the weld pool, so you need more heat because of that. And the third reason is you weld it on AC, which ends up putting a lot of heat into your tungsten and not into the base material. So those three things combine to require massive power, and this is the biggest mistake people make. If you have ambitions on welding aluminum, the bare minimum welder you need is 200 amps, period. Anything less than that, and you're not going to be effective at aluminum. And by the way, 200 amps will only allow you to weld about 3/16 thick aluminum. That's not very thick. I have personally used 200 amps full pedal on 1/8 inch aluminum, depending on the joint that I'm welding and the filler rod size. So it's no joke. Do not skimp on amperage with aluminum. A lot of people see these big 300-400 amp TIG welders and are like, why on earth would you need that? It's because of aluminum. Having that much amperage allows you to weld 1/4 inch thick aluminum with no preheat. Now, that is always an option. Many a day on a 200 amp class machine, if I welded 3/8 or 1/4 inch aluminum, the problem is with that is you have to preheat it stupidly hot to make it work, and that's not really the best way to do it. So you're better off with a 200 amp plus machine to get it done. So if aluminum's even in the ballpark, 200 amp minimum. And by the way, like I said earlier, do not trust the Amazon specials. They'll be happy to charge you $500, take your money, and sell you a 200 amp aluminum AC TIG welder when it actually puts out 160 amps. And then when you go and try and weld aluminum, you don't understand why you can't make a puddle properly. So don't skimp on it. Aluminum is big. And by the way, almost all of the cost in a TIG welder is not the DC end. It's all in the AC control that costs all the money. So if you have no ambition on welding aluminum, you can get a hell of a good DC TIG welder for not a lot of scratch because it doesn't have all the AC capability. Now there's another thing dealing with this that you probably didn't think of that is very important with TIG, and that is minimum amperage. This is something that is somewhat grossly exaggerated on a lot of cheaper welders. They'll claim they weld from 1 amp to 200, yet they don't. And it sounds like this is nitpicking, but trust me, it's not. What you will universally find is that cheaper welders, TIG welders, will only drop to about 20 amps. So that's very common. Now, 20 amps isn't a lot, but if you're welding something like auto body thickness steel and you back off that pedal and that puddle, you're trying to control it to where it doesn't blow through, 20 amps might not be low enough for that material. So what you find with higher end welders is they'll go down to 10 amps, 5 amps, 2 amps, and 2 amps is a bit ridiculous, or like the Dynasty I have, I think goes down to 1 amp. You want good low end. So something that goes down to 5 amps is really beneficial on super thin material. It will help you out from blowing a hole. So that's something to consider. Most manufacturers, good ones, will put a minimum amperage spec. If it says 20 or 30, my suggestion is find a different welder. With that said, can you do a lot with it still? Yes. It's just on super thin stuff, it's going to be more frustrating than with a better low-end machine. Now, speaking of other amperage things, let's talk about arc starts. So the arc starter that's in the machine does make a difference, and I talked a little bit about this in a previous video, but I'm going to talk about it more now. So the arc starter is basically what amperage the initial arc starts at. So it's very common, like if your machine only goes down to 20 amps, that it starts at 30, so a pretty high amperage start, and then it immediately slopes and backs down to the resting amperage. This 30 amps arc starter is perfectly fine if you're welding stuff thicker than, I don't know, 1/16 and thicker. The problem becomes if you want to weld like auto body thickness or thinner, having a 30 amp start, you're going to tend to blow a hole immediately when you start it. And all those guys on Instagram that weld, razor blades together, and I've done it too, having a really low amp arc starter allows you to arc start directly on the razor blade rather than on something near it and then weld over to it. How critical is this? Honestly, if you have somewhere between a 10 and 20 amp arc starter, you're okay. You're going to find that a lot of the cheaper machines out there are 20 plus amps, and that will cause you to struggle with thinner material. Now, if you do happen to have a hotter arc starter, there are ways to deal with that. And one of the long-term viewers of the channel has mentioned multiple times, and thank you for mentioning it, you know who you are, and this tip will help you immensely if you have a hot arc starter. This is a bit ridiculous, it's a copper bar, but if you were to use a chunk of copper, a little sheet of copper, put it next to where you're TIG welding, start the arc on that, and then come over and bring the arc to where you're welding, that will completely eliminate the hard arc start. So using copper or a piece of aluminum, preferably copper because it doesn't react as much with DC, will help you out. So in a pinch, definitely do that. The last thing regarding arc starters we're going to talk about is a maintenance related issue, and that has to do with the points that some of them use. So if you have an older transformer machine or even a Miller Dynasty 200, so the precursor to the 210, a lot of those older machines use what's called points, and all they are is basically two metal round discs of sorts, and it is at a specified gap. Now this gap is far too big. You actually use feeler gauges to adjust the clearance. They're very close to one another, and more or less it controls how much voltage builds up in the arc gap, and it controls the arc starter. Well, those older machines over time will get erosion where the points start to erode, the gap, maybe the machine was bumped too many times or just wore the gap gets too large, and dust and material will often build up on it, which all affects the voltage that's required to cross the arc gap in them. So your older machines, it's very common to have to routinely, aka once a year, take some emery cloth, polish the surfaces, take a set of feeler gauges, and gauge the gap on them to get it within spec. And that's one of the reasons why it's very common to find people selling older TIG machines where they say, the arc starter doesn't work that well. Like 1 out of every 5 arc starts, it doesn't start. And they think that the board's going to go out when the reality is the points are just dirty and out of spec for clearance. So if your machine has those, and reference the manual to find out, it's best to have that cleaned and in spec. It's very easy to do, and it will help your machine start the arc better. Modern machines like my current Dynasty, that uses a solid state high frequency high voltage starter, and when that breaks there's no adjustment. You just pay Miller $1,000 to fix it for you. So a little bit different with some of the modern machines. Alright, so it's going to be a while before I get to how to AC TIG weld aluminum, but since I'm talking about machines and I'm trying to help you guys get a machine that's going to do what you want without wasting too much money and in buying too much machine and without getting screwed, if you know what I'm saying. So there's a couple key things you need to pay attention to. The first one is the AC frequency. Old school transformer machines like your dial arc 250s, your tombstones, all of those, a lot of them with a simple set-top box, you can actually AC TIG weld. The problem with that is almost all of them, the simpler set-top boxes that go with those transformer machines, are fixed at 60 hertz. Now you can do a ton of aluminum welding with 60 hertz for a frequency. The problem is if you're trying to do smaller welds on thin aluminum, the 60 hertz produces a wider arc cone and thus a wider weld. So it can be difficult to weld thin material at 60 hertz over a higher frequency. So realistically, you should be looking with a machine with adjustment between at least 60 hertz and 120 hertz. I find that that is a very good range to work with, and it can do a lot. Now, higher end machines will often go down as far as 20 hertz, so that's how many times per second it switches positive to negative, and they might even go above 400 hertz. My opinion is below 50, 40 hertz doesn't do much, and above about 200 doesn't do much. So having capability outside of that range isn't buying you a lot, especially if you're trying to learn. Not a huge difference. Amperage is a better thing to buy into. Buying a more powerful TIG welder rather than one with more adjustment frequency is far better for aluminum. Now for AC balance, I understand you probably don't know what that is, but I'll simply explain it as that is how much of the AC wave, which AC is like this, the output of the machine, how much of it is negative and how much is positive. Some manufacturers use their balance to describe how much positive, and some of them most of them use it to describe negative. You want a machine that can do 60 to 90% of the AC wave as negative, so penetration. Sometimes they might say that 40 to 10%, that would be, they're referring to the same thing, they're just referring to the other end of it. But anyways, if you have a range of 60 to 90% that it spends on the negative side for AC balance, you can do pretty much anything you would want to do. Now, I'll be honest, a lot of machines don't go as high as 90%. Is it a big deal? Probably not. If it gets to 80, you're still okay. Because most welding with aluminum, for me, is between 65% and about 75% AC balance. So if you're in that range, you're okay. Where the 90% comes in, if you want to use aluminum bronze wire and braze with it, 90% balance works great. Just a hint of AC, more or less, will help clean the puddles. So that's a benefit, but a lot of machines, especially cheaper ones, aren't capable of that. So it's not a huge detriment. It's just something to think of. Now, pulse, very hot topic with aluminum. For you beginning and with a 200 amp machine, pulse is irrelevant on aluminum. That's my opinion, and I'm sticking to it. Aluminum has a property called hot shortness, where when you heat it up hot and then let it cool fast, it cracks. When you introduce pulse with AC welding and you don't know what you're doing, you will produce cracked welds whether or not you see it, and they will fail on you. So my recommendation is do not use pulse with AC. And this also coincides with the fact that most machines are only 200 amps. When you add pulse on 200 amps, your heat input can get as low as 140, 150 amps. You're not going to be able to weld much aluminum with pulse because you don't have the heat input. You need heat input to weld aluminum. So again, my recommendation, you don't need it. And you can make a perfect stack of dimes that looks awesome with aluminum with no pulse. Nobody uses pulse for aluminum to get a stack of dimes look. So that's really irrelevant. Now, something that isn't irrelevant is duty cycle. Most machines on DC, you can weld almost all day at 120 amps and not really be worried about kicking the machine out. On aluminum, that's a hugely different story. Because so much of the aluminum requires high amperage, you will run up against your duty cycle. If your anticipation is to do a lot of aluminum practice and a lot of aluminum welding, look for something with a 60% duty cycle above 140, 150 amps. You need the capability of outputting a lot of power over time. Most cheaper welders will, at 200 amps their max output, might have a 15% duty cycle. Well, guess what? Even if you swap out the TIG torch so that doesn't melt, you're going to weld for 2 minutes, the machine's going to shut down on thermal overload, and now you're not practicing. So aluminum is absolutely critical to have either a 250 to 300 amp machine so you get the duty cycle, or a better quality 200 amp machine that has a good duty cycle, because that will keep you welding and not waiting for the machine to stop complaining to you that it's melting. The last thing regarding AC capability has to do with waveforms. Now, a conventional AC waveform is a sinusoidal wave like this, where it's more or less round. With TIG welders, a lot of them use what's called square wave. Square wave is more or less, it's switching between positive and negative, and it immediately switches. So it goes like this. It does not slowly taper. The benefit to square wave is it tends to freeze the molten aluminum puddle faster, and it kind of gives you more control. Most good AC capable TIG welders all weld on square wave output. All the older transformer machines universally only weld on sinusoidal. So if you want the best capability for aluminum, especially thin, look for something that's capable of square wave. Now, a lot of machines like my Dynasty and a ton of them out there can do other waveforms. So they can do a triangular and other variations of that. Well, for the most part, I hate to say it, but they're kind of a gimmick. Okay, I said it. Square wave and sinusoidal will do almost everything that you need to do in high quality welds at that. In specific instances, like under production work where you absolutely must have perfect welds, doing a triangular wave can control heat input better because the average heat input of it is lower than this. Okay, but you can also just reduce your amperage to get the same effect. So my opinion is stick with square wave. It works great. You don't really need more than that to do excellent welds. All right, back to where we started here. So in a future video, I am going to do a opening of this case, and we're going to talk about the build construction, because I have absolutely no idea of what's in here. But we'll talk a little bit about the components of a TIG welder via that video, and we're also going to determine if this machine is worth buying. Now, one of the things that I cannot demonstrate to you guys easily has to do with what I call the quality of the TIG arc. I've been TIG welding for a long time and have a pretty high skill at it. I can pick up any TIG welder, use it for 5 minutes, and give an opinion on the quality of the arc, how smooth the foot pedal adjusts to amperage, how nice it starts, how responsive it is to my input, and just how it welds. And that's something that I can't possibly demonstrate fully through a video screen, not to mention you really have to try it for yourself. And I've welded with a ton of TIG welders, and I know that there is a massive difference between them. And that's where the unfortunate truth is that when you only look at spec sheets on welders as to what's better than what, you miss out on a bigger picture of what actually welds decent, because you can't really quantify that in a list per se. And what I have universally found is that higher end machines flat out TIG weld better. They have lower amp starts, they have lower amp minimum amperage, they have higher duty cycles, their foot pedal controls are smoother, their dials are more accurate to what you want. So if you want 160 amps, it gives you 160 amps, and they just work better. And that's something that you don't see in spec sheets, because remember, these companies out there, they'll lie about everything, because if they sell 1,500 machines and double their money and then disappear overnight, they don't care, okay? So it's something to keep in mind. And I know that good machines cost money, and TIG is not cheap. It's not a cheap hobby. It's not cheap to get into. That is the reality. However, you don't need to spend $5,000 for a machine. Today, thankfully, you can spend $600, $700, $1,000 in that ballpark and get a phenomenally good TIG welder. So you're lucky that you're starting today and not 20 years ago, because it was far more expensive then and far more uncommon then than it is today. So anyways, with that said, hopefully this video helped you understand a lot more about the features, what that you can spend your money on, what that things you don't need, and it will help you make an informed decision on what to buy. And like I said, take a look in the video description, because I put a list of a lot of welders that I think are solid and that you can get to the finish line with. Trust me, if you get into TIG welding, you're going to end up upgrading from your first machine anyways. So don't look at spending a fortune to get something like a Dynasty when you don't even know if you want it. Get a solid machine and upgrade as needed. Which, by the way, my first TIG welder was actually a Lincoln Electric TIG 200, and that is universally considered a crappy TIG welder, yet I built many thousands of dollars of stuff with it, and it paid for itself 10 times over, and I ended up selling it for almost what I paid it for it to a guy who is still using it to this day to build stuff. So buying better equipment in a long run does pay off. So with that said, thanks for sticking around for the video. Until next time.